again. Here we are with Module 2, Lesson 4. Our learning target for today being that we can understand the rules for adding integers with the same signs as well as with different signs. And absolute value is going to be highly important in this lesson. So remember that absolute value is a number's distance from zero. And we're going to be able to use it to our advantage at the end of this lesson today. My hope is that if we're in class for this lesson, we'll get to do a warm-up with whiteboards and do some more partner work, but we will just see about that. As for the lesson, let's go ahead and get started. Here's example 1, and we're going to be looking at rules for adding integers with the same signs first. So we're going to go with something that's familiar. And you see that the numbers that we are presented with in part A are 3 and 5. So we're just doing 3 plus 5. Okay, so let's just break it down and really think about how absolute value applies here and helps us to add these numbers efficiently. So I know that I'm always going to start at 0, and they ask us how long is the arrow that represents 3? Well, 3 is a positive number, so I'm going to go 3 to the right, and this is my vector here representing 3. So, of course, the absolute value of 3 is 3, so that means that it's 3 units from 0. And being that it's positive, you should have it pointing to the right of 0. All right, now if I want to take 3 and add it to 5, I know that I must continue on, and being that they have the same signs, I can just actually continue that vector that I started, to represent 3. And if I move 5 more spaces to the right, I see that my sum, of course, 3 plus 5 we know is 8. So the sum of these two integers would be 8. And if we were to represent the sum using an arrow, how long would the arrow be? So I have to think about combining these two absolute values in my head. The absolute value of 3 plus the absolute value of 5. I could have just drawn one vector that was 8 units long. Okay, so how long would my vector be? My vector would be 8 units. And these are two positive integers that I'm working with, 3 and 5. So it would point 8 units to the right. Now let's continue to see how absolute value, why do we keep talking about absolute value? Why is it so important? Okay, we're about to see why. And this was page 17. And now let's flip over to page 18, where they ask us some more questions to get us thinking a little bit more deeply about this topic. So what is the relationship between the arrow representing the number on the number line and the absolute value of the number? They keep asking us these same questions over and over to make sure that we understand. So we know that absolute value can be represented by a vector for any number. Okay, so if I wanted to represent the absolute value of 10, I would draw a vector that's 10 units long. Let me get this out of the way. Okay, so actually I'm gonna put it way up in the corner right there. All right, so do you think that adding two positive numbers will always give you a greater positive number, and why? Okay, so I'm going to ask you to put your answer to this question in the comments on this video and give me some feedback. Let me know what you think. If I add two positive numbers, am I always going to get a positive number? And explain why. Okay, so I look forward to seeing your answers there. Now let's see this applied with two negative numbers, such as -3 and -5. Okay, so let me get started with my vectors. So let me think about this. The absolute value of -3 would mean that I have to move 3 units to the left of 0. Okay, and I'm going to add that to the absolute value of -5, which if I keep going 5 units to the left, I'm going to arrive at my sum of -8. So I drew a vector that was 3 units long and a vector that was 5 units long. So my vector altogether should, actually, that's kind of confusing. I just noticed that I switched them up. Here's my vector that's 3 units long. Here's my vector that's 5 units long. I could have just drawn a vector that was 8 units long, but being that these were two negative numbers, I would have gone to the left instead of the right this time. Okay, so if I look at the sum of -3 plus -5, I would see that I arrive at -8. Now, absolute value was a little more helpful in this than it was with the two positive numbers, but if we are working with two different signs, then absolute value can definitely serve its purpose and become helpful. So this was page 18. Let's go ahead and flip over to page 19. And I want you to answer this question. Do you think that adding two negative numbers will always give you a smaller negative number, and why? Think about these words here, smaller negative number. And think about what negative numbers are before you answer this question, okay? Because you may be thinking, oh, well, I added -3 and I got to -5 and I got -8. Isn't -8 a larger negative number than either one of these? Well, if you remember, whenever we first talked about negative numbers, we said that the further to the left we go, the smaller the numbers actually are. I'd much rather pay $3 for something than pay $8 for something. You see what I mean? So -8, even though the number attached to the negative sign is actually larger, since it's negative, it represents a much smaller number than what I started off with. Okay, so let's put your answer to that question. Do you think adding two negative numbers will always give you a smaller negative number, and why? Put that in the comments. Okay, so if we look at what both examples have in common, okay, the first one that we did where we added 3 and 8, where's that page? Let me grab that. How was this adding 3 plus 5 similar to adding -3 and -5? How are those two examples similar? What do they have in common? So you might be saying both pairs of numbers, or integers rather, had the same sign. Okay, so I'm expecting two questions being answered in the comments from each of you, giving me an answer to those two questions I asked you to answer in the comments. Okay, now exercise 2, I'm going to ask you to wait until after the video is over, so complete once you finish the video lesson, just so that you're not distracted. And you're going to see these numbers have the same signs, correct? -4, -2, 5 and 9, -6 and -3. So we're just practicing those rules for adding numbers that have the same signs over and over again. Okay, so complete exercise 2 after the video lesson, which I still need to show you how to add numbers that don't have the same signs. Okay, so this is where absolute value, I keep talking about absolute value. this is where it's really going to come in handy. Okay, so I need to add 5 and -3 on this one. So I need to know the absolute value of 5 to draw my vector. So I start at 0 and draw my vector 5 units to the right for that +5. And I'm going to add that to the absolute value of -3. So I need to be drawing a vector that is 3 units long. Oops. I need to be drawing a vector that's 3 units long, but since it is a -3 that I'm trying to represent, I need to draw it to the left. And I'm going to start where I ended my last vector. So 1, 2, 3. When I arrive at the end of my last vector, I see my sum. So -5 plus -3, I see equals +2. Okay. So now let's look at an example that uses numbers that are a little bit more difficult. I want to represent 4 plus -7. We had seen 5 and -3 in another example somewhere, but we've never used 4 and -7. So I'm going to take the absolute value of 4 to start off with. Let's go to 0. Draw that vector that's 4 units long. Here I am at +4. Okay, I'm going to add this to the absolute value of -7, where the absolute value of -7 is going to tell me how long my vector needs to be. So I'm going to start off here where I ended last, and I'm going to draw it to the left because 7 is negative, but my line is going to be 7 units long. So 1, 2, 3, 4, 5, 6, 7. And here I am at -3. So in these examples above, what is the relationship between the length of the arrow representing the sum and the lengths of the arrows representing the two addends? So let's break this down right here. This is a bit vocabulary heavy. What is the relationship between the length of the arrow representing the sum and the lengths of the arrows representing the two addends? They have the word "to" before this vocabulary word addends right here. So I can assume, since we're talking about two numbers in this last example, that addends are numbers that are added together. Okay, so they're asking me what is the relationship between let's see how to explain this. I needed to get 2 arrows. I needed to draw 2 arrows to represent the two numbers, when in reality, I could have just started at 4 and drawn my arrow to the left to meet this -3 here, right? Because I started at 0, I went to 4, and then I started at 4 and went to -3. So what they're asking us to do is they're asking us to begin going straight to the number on a number line rather than starting at 0, going there, then going here, then going there, going back and forth and confusing ourselves, because you know that sometimes the more often that you do something, if you continue doing it the same way, it can become kind of confusing. You learn shortcuts, you learn tricks, okay? So they're asking us, could I have just drawn one line instead of 2? Could I have just drawn 2 vectors, one vector instead of 2 vectors? The length of the arrow that represents the sum can be just narrowed down. Oops, my highlighter is a little bit dried out here. It can be just narrowed down to this one right here. They're asking me to cut out this middle step right here of starting at 0 and going to the first number and then adding the second number. So the length of the arrow that represents the sum is the same as the vector that represents -7. Because that's what I did right here. When I got to 4, I added my -7 and I ended up going back to -3, which is my sum. So I don't need to be doing this anymore. I could if I wanted to be mathematically correct, but sometimes you just don't have time for that and you need to get straight to the point, right? So let's see, write a rule that will give the length and direction of the arrow representing the sum of two values that have opposite signs. So if I want to add, because that word sum means add, if I want to add two values with opposite signs, I can begin my vector at the last, no, not at the last. I would begin my vector at the first value because we started at 4 with this example, okay? And even in our last example, if you look, where is that? See, I could have just started at 5 here and then drew my vector representing -3, and I would have gotten the same result. They're telling me that there's no need to do this anymore because we are combining all the ideas that we've been working on in the last few lessons, and we're taking a shortcut. Okay, so I can begin my vector at the first value and draw my second value directly to my sum. Okay, so if I want to add two values with opposite signs, I can begin my vector at the first value and draw my second value directly to my sum. Okay, so let me see if there are any other examples here. Okay, and let's see, I'm going to stop for a second here. This is going to be a two-part video because I need to look ahead at this example 3 and think about how I want to explain it to you guys. So be on the lookout for lesson 4, part 2.